This section examines the relationship between cyber-physical production systems and the Internet of Things. It includes a review of a range of wireless communication protocols available for the smart factory and analysis of the principles and benefits of cloud computing and its role with suppliers, manufacturers and customers within industry. It concludes with the results of our investigation into the challenges and solutions regarding data analytics in smart factories.
Cyber-physical production systems are integrations of computation, networking and physical processes. Cyber-physical systems for production that consist of many distributed elements which can process data and make some decisions. These elements can communicate across and between machines, humans and products. In our organisation, the paint robots communicate with various systems and humans to run efficiently, including each other, ensuring their location and comparing process steps. The product RFID tags on the product gives the robots the ability to check the product is correct and automatically load paint materials for the paint process. The spray booth, they constantly monitor the spray booth environment parameters including downdraft temperature and relative humidity. Lastly, they communicate any faults such as material availability, pressure and or power spikes or drops, environment anomalies, to name a few, to each other and robot operators so the issues can be investigated and resolved quickly.
Architecture. Architecture of cyber physical systems is defined as an integration and computation of physical processes. Architecture of CPPS supports the right timing, delivery, exact insights to the right personal to support wiser decision making within the industries. Also, there are core technologies of big data allowing machines to become self-aware and intelligent. There are 5 layers that make up the architecture. They are configuration levels, which is self-adjustment and verification of self-configuration. Cognition level is remote visualization of human interaction and decision making. Cyber level is known as a twin models, components and machines and similarity in data mining. Data to information, also known as multi-dimensional data correlation, is performance and prediction of data, and also the smart connection level, sensor networks and free communications. This helps to instruct and make decisions. Also, the core technologies of big data become self-aware. These help with industries.
Cyber-physical systems bring with it many benefits and advantages, ranging from dealing with uncertainty, increased system performance and aiding integration to assist with the interaction between humans and systems to aid scalability and flexibility. The integration of cloud-based systems and wireless sensor networks help to create an integrated system allowing for immediate access control techniques. This is the allowing of signals to be transmitted across cabling, one machine at a time, in order to transfer data, machine transactions and help identify fault tolerances. Given the ability to expand, develop and further integrate cyber-physical systems, the level of flexibility achieved far outperforms that of the cloud computing systems or wireless sensory networks when implemented in isolation.
Support and training for the workforce. The application of cyber-physical production systems gives us a new innovative ways to train the workforce. These can be the use of virtual instructions and information displayed to the trainee whilst carrying out physical exercises. This can be displayed through digital screens close to the operator, or even through innovations like Google Glasses, giving us the ability to have important information streamed instantly to us. At Rolls-Royce, we use this technology to continuously maintain knowledge throughout the workforce. We do this by having critical information such as specifications, dimensions, through CAD data or gap plans that are directly available through interfaces to all associates on the production line.
So artificial intelligence is quite common in the industrial revolution at the moment. So if we talk about the prediction of large data through artificial intelligence, we have machines that be able to predict for instance, driverless features, so advanced driving features that connect to the vehicles, monitoring sensors that issue, for instance, warnings and so forth, driver monitoring that can detect behaviours of the drivers, or obviously recognitions. An example is a computer starts up, and as you jump into your car, it will recognise that the driver is yourself, and it will adjust the car to the specification you require.
Connectivity is a big part of Internet of Things. So it refers to the internet connectivity within physical devices and everyday objects. These devices also have the ability to connect with each other, and they can be remotely monitored and controlled. A Hive Home system is a good example of internet of connectivity, where a person's house can be remotely controlled via their mobile phone anywhere in the world. Internet of Things has come under criticism due to privacy and security concerns as to how easy it is to hack the connectivity systems.
Sensors are also a huge part of things. It comes from collecting data from the environment to sending the data to the cloud, for the cloud to then use software to process and send back to the end user. So a great example of this is a smartphone. Different applications require different types of sensors depending on whether they're digital or analog. Common sensors include temperature, humidity, motion, gas, smoke and pressure. For example, used in agriculture to measure soil temperature, water and plant temperatures. And in manufacturing of automotive, so a great example of that is new cars now tell you when the pressure of your tyres are low, comes up with an alert.
So the smart factories of the future will analyse and manage applications. It is essential to get value out of the Internet of Things. The platforms promise to the system in Industry 4.0. So there are 4 types of platforms. So we have end-to-end, which offers platforms for hardware, software, security and management tools and device connections. The cloud offers a platform for services to be monitored simultaneously with devices connected. Connectivity and management of platforms, which is a low-cost solution used by Wi-Fi. Data platforms, which enable combinations of a number of devices to route device data. So the benefits of suppliers and customers by using the internet connection. So within the automotive industry, connectivity tools will be able to collect data and transfer in real time. This would give real-time evaluations of data, potential risk values in cars, and obviously highlight any issues during the manufacturing process.
Okay, so wireless communication protocols. The first one is NFC, so near field communications. You'll see these commonly used today in contactless payments.
RFID, radio frequency identification, used automatically to identify and track objects throughout. With electronically stored information tags, track anywhere, it can track objects anywhere through its processes.
Bluetooth is a wireless technology standard for exchanging data between fixed and mobile devices over a short distance using short wavelength UHF radio waves, and its uses include tethering, which is sharing of an internet connection from one device to another, transferring files, playing multiplayer games on 2 separate devices, and to control home security gadgets. And one of the most common uses is to connect your mobile phone to your vehicle.
Low energy wireless. This is a personal area network developed to meet the increasing demand in the market for Internet of Things products. A suitable protocol to use with devices that run on batteries and that need to last for a long time. At Rolls-Royce, this could be devices that we use for dynamic check fault capturing, which are handheld battery devices that display a list of quality checks to carry out on the product at certain intervals of the process. The checks select either OK or not OK by the operator, and the device sends the data wirelessly to a central system which logs if there is a not OK capture. This data is then then stays in the system logged to the VIN number of the vehicle to give a transparent view of the vehicle defects that require attention.
ZigBee aims to provide a foundation of Internet of Things with features to support low-cost, highly reliable networks for device-to-device communication. For example, utility companies use ZigBee in their smart meters to monitor, control, inform and automate the delivery and use of energy and water, as well as give the consumer their information and automation needed to reduce energy use and save money. Z-Waves also aims to provide the foundation of Internet of Things. Similarly to ZigBee, it's used in smart home networks to enable the user to make a command on a device such as a smartphone or hub, and it routes this onto the destination. For example, asking Alexa to turn on the lights.
Fred, this is an IP-based secure wireless mesh network for home and connected products. Fred networks allow for each product to use and share data between them. This results in each device becoming a router and may give a very stable network with a large reach.
LTE, long-term evolution advanced, is most commonly known in connection to mobile communication standards and as an enhancement to LTE. LTE-A is able to provide theoretical download speeds of 300 megabytes per second, which is 97.54% greater than that of speeds available through other connection methods such as 3G.
So a Wi-Fi standard is enabling devices to connect with each other without requiring a wireless access point. Wi-Fi Direct allows two devices to establish a direct Wi-Fi connection without requiring a wireless router.
LPWAN stands for Low Power Wide Area Communications Network. So this is a device at Rolls-Royce where an associate on the line can order a part straight away by clicking on an app, brings up all the specification of the car and sends the communication across to the offsite warehouse where the part can be ordered within speed.
Light Fidelity or Li-Fi is a visible light communication system which runs wireless communications that travel at very high speeds. It has the ability to turn household LED light bulbs into routers to enable data transfer, boasting speeds of up to 224 gigabytes per second.
Big data. Extremely large data sets that may be analysed automatically using computers to reveal patterns, trends and associations, especially relating to human behaviour and interactions. Big data can be seen in scanner machines whereby hundreds of thousands of data points are taken every second, which are converted into a digital image of a part or product. Big data within automation enhances the improvement of process and the feedback given from machines and robots.
Cloud computing. This is the practice of using a network of remote servers hosted on the internet to store, manage and process data rather than using a local server or personal computer. There are four main types of cloud computing. These are infrastructure as a service. This is where a provider will deliver a pre-installed and configured hardware or software and allow the business to use them as they like. Then they have a platform as a service. This is more advanced than the infrastructure service, as the providers will also offer a computing platform and a solution stack as a service, along with the infrastructure. Then there is software as a service. This is a fully functional web-based application on demand to customers. So this allows business users to access emails, project tracking, and conferences anywhere in the world. And then finally, there's a recovery as a service. This is a service that allows businesses to combine all of their backup, archiving and disaster recovery solutions into one single platform. So, in this presentation, we've examined the relationship between cyber physical production systems and the Internet of Things. We've then reviewed a range of wireless communication protocols available for smart factories. From our investigations,
from our investigation, we looked at the challenges with data analytics within a smart factory, and we've put them onto a board and highlighted where they are. So within the data analytics of a smart factory, we've highlighted several challenges and then come up with some proposed solutions. For example, one of the challenges would be lack of skills, so the employees in the business maybe not understanding how to use the data and how to analyse it. As a proposed solution, we've suggested more further training to make the employees understand how to analyse the data and how to display it. Another example would be the volume of data, with Industry 4.0 now creating excessive volumes of data. It's very difficult to be analysed manually. As a solution, we've recommended making this more automated and using systems to do that analysis for us. Also, we have analysed the principles and benefits of cloud computing and its roles with suppliers, manufacturers and customers. So to do this, we've looked at the key principles of cloud computing and what they're there to do, where we've used them in our business, so in different technologies across the business. So some examples would be the internet storage is a principle of the cloud computing, the recovery system, so when the systems go down we can recover the information very quickly. And this leads into some of the benefits that we have. We see a big benefit in space saving because we don't have to have servers on site, we can store our information in the cloud, and in a manufacturing plant, space is a lot of money. We also looked at how it affects some of the suppliers. A key one for our business was problem solving, quick problem solving. We can get big data files to the supplier very easily and very quickly, allowing for the quick problem solving and transparency. And then also how it's affected customers, internal and external. Again, having the global access, because they don't have to have a server on site, everyone can access the data and it's quick and very visual. At the bottom here, we've gone on to the main roles of what we deemed cloud computing to be, and that's to be for the efficiency of the business, the connectivity, so being able to connect with all devices on site, and the collaboration between all of the departments. So, yeah, in summary, that's it.